Okay, so we're going to start with just exploring some data. In this unit, we're going to talk about categorical data, and then we're going to switch over to quantitative data. We're going to talk about the difference of the two, and then with quantitative data, we're going to talk about how you can display it with graphs, but then also how you can describe it with numbers. So let's start with a really basic definition of statistics. It is the science of data. It is the gathering of information, the computing of some numbers, and then getting some numbers that represent that data and interpreting what those numbers mean, and then also presenting that information in a way that's user-friendly. Data analysis is the process of organizing, displaying, summarizing, and then asking questions about data. And those verbs really describe everything that we're going to do for the next year. Definitions. Okay, so let's talk about an individual. An individual is an object described by the set of data. And that object can be a person, it could be an animal, could be cars in the parking lot, could be fish in the pond, could be people sitting in a math class, or it could be people sitting in C building. It could be schools in the United States. So it's the object that's being described. That's the individual. The variable are the characteristics of those individuals that are being described. When we talk about variables, we have two different types of variables. We have categorical variables and we have quantitative variables. Categorical variables place an individual into one of several groups of categories. So if I did hair color, because you are blonde or brunette or redhead, it kind of puts you in a bucket with other people that have that same categorical variable, puts you in a category. Let's see, quantitative. So that's anything that takes on a numerical value for when it makes sense for you to find the average of that value. So an example would be age. So that's a number. And it would make sense for me to say, let's find the average age of a student at South Stokes. Someone's height, or a group's height, income, GPA. Those are all numerical values for which it makes sense to find an average. Now, what you have to be careful about is just because it's a numerical value does not mean it's quantitative value. Sometimes a numerical value can be kind of considered a category. So where it makes sense to find an average really helps you distinguish between what's quantitative and what's categorical. If I said, hey, what TV station are you watching the most? And you said channel 12. And someone else said, well, I watch channel 22 or whatever. If I took all that information, even though those are numerical answers, would it make sense for you to find the average channel number that someone's watching? Or would it make more sense for you to figure out how many people are watching each channel and show the distribution by more like a category? So a channel, even though it's a number, is really a category. It just happens to be named with a number. Okay, so a high school student database includes data about every currently enrolled student. Okay, so we've got a database. It's got all our high school students, and it's got all kinds of data about you. Everything from your parents' names to your address and phone numbers and emails, to GPAs and test scores and courses that you've taken, and things like that. So if we think about that set of data, think about who the individuals are. So the individuals are the students, because those are the objects for which we are collecting the data. The variables are going to be all the pieces of data that we collect. So I'm assuming like your age, your gender, and then things like GPA, maybe your grade level, etc. So all of those things would be variables. So examples of categorical variables would be gender, grade level. Even though your grade level is a number, 9, 10, 11, 12, it would not make sense for me to say, well, if I find the average grade level and get a 9.2 or a 10.7, like that doesn't make sense. So grade level here is a category. It's just the name of the category that we're putting you in. Another categorical variable might be your zip code. That kind of puts you in a geographical category. Examples of quantitative variables would be your age, because it would make sense to find the average age of somebody in a particular group, and GPA would be another one. Okay, so in looking at this, and it may be really small on your notes, so maybe looking at it on here will help you be able to read it. So it says Census at School is an international project that collects data about primary and secondary school students using surveys. Hundreds of thousands of students from Australia, Canada, New Zealand, South Africa, and the UK have taken part in the project since 2000. Data from the surveys are available at project's website. We use the site's random data selector to choose 10 Canadian students who completed the survey in a recent year. The table below displays the data. Okay, so based on this, I want to know who the individuals are. Well, the individual they're not all students. It's not the hundreds of thousands of students from all these different countries. It's 10 Canadian students, because that's what this data is about. So this is the 10 Canadian students, because it's asking us what this set of data is about. Variables, and we want the categorical ones and the quantitative ones. So let's see, we've got gender, language spoken, if they're right-handed or left-handed, their height in centimeters, their wrist circumference in millimeters, and their preferred communication. So categorical would be what kinds of things put them in a category, and that would be gender. The number of languages that are spoken, that would be quantitative. Because it would make sense to say that the average number of languages spoken was 3.2. Handed is a category. You are either this or this. Height is going to be quantitative. So is wrist circumference. And preferred communication, again, that's going to put you in a category. So that's categorical. All right, and then it says describe the highlighted student. We're not going to write this out. This is like super easy, so we're just going to state it and then move on. The highlighted student is from the province of Ontario. And Providence is also a piece of information, and that would be a category. So the province is absolutely categorical data. Sorry, I skipped right over that one. Okay, so describe the highlighted student. So our highlighted student is from Ontario. He is a male. He speaks 4 languages, which is well above average. He is left-handed. He's 157.5 centimeters high, has a wrist circumference of 147 millimeters, and he prefers text for communication. That's it. It's that easy. Okay, a variable is a piece of data that varies. So all of these in here are all, like the handed, that's a variable because it varies between right and left. The number of languages spoken is a variable because it varies based on who we're talking about. So a variable is a piece of data that varies. Quantitative, so things that can be measured by numbers where it makes sense to take an average. Variables have values that are very close together, or they can also be very spread out. A variable generally takes on many different values. In data analysis, we are interested in how often a variable takes on each value. And again, if this table is really small in your notes, hopefully this should help make it a little bit more clear, although it is a little hard to read. So we're going to talk about a distribution. A distribution tells us what values a particular variable takes and how often it takes on those values. So a distribution only looks at one variable, and it's looking at the spread, the distribution of that variable. So what we've got here are models of cars and their average miles per gallon. So our variable of interest is miles per gallon, and then what we've made is a dot plot distribution. So in this table, it's really hard to see which one has the most miles per gallon, which one has the worst miles per gallon. But if I put it in this dot plot, it's really easy to see that I have a nice cluster of data here. I've got some really good gas mileage going on way down here, and then these guys are what we would call outliers. They're just really, really terrible miles per gallon and very far away from the pack. So it's very easy to see the variability. That's a really good buzzword for statistics. We're going to use that a lot. The variability of our variable. If I had a dot plot and they were all right together and there were none out here, then I would say that my data is not variable. It's very consistent, but this data is widely spread. So again, putting it into a distribution helps us visually gather some information, draw some conclusions about the variable that we've collected our data upon. So how to explore data. You can examine each variable by itself, and then you can study the relationships among those variables. So you can start with a graph or graphs. So there's our dot plot. And you can also do numerical summaries, which we will do in Unit 1, where you gather a mean. We've got a standard deviation here. Like, we've got some really good information that we're going to dive into, and I'll explain what all the symbols mean and what the numbers mean and how you interpret. You can find general information from data, average, mean, standard deviation, which talks about the variability. So, a nice overview from data analysis to inference. And inference is a great word. Inference is when you draw conclusions that go beyond the data at hand. So I'm going to collect this data, I'm going to interpret it, I'm going to put it in a graph, and then I want to draw a conclusion based on that. So I've got my population. But normally it's very, very difficult, very inconvenient, or very expensive to get data from an entire population. So then what I'm going to do is I'm going to take a sample from that population, and we're going to talk a lot about how to take a sample, a really good sample. We're going to take that sample, and first up, we're going to collect data from that sample, and then we're going to perform some data analysis on that sample. And then we're going to draw some conclusions about the sample and project those conclusions to our population. So it makes really good sense that we need to get a really good sample that's very representative of our population, because our results, our inferences are going to be projected onto our population.